we are. Let's follow the same strategy. Again, it's about getting our diagram to be as useful as possible from the information that gets given to us initially. So over here we're told that ABC is a tangent to the circle at B. Right over there. So let's start thinking about our tangent theorems. Okay, and then from C a straight line is drawn parallel to BF. Okay, there we go. That's what they're talking about. That line is parallel to this BF dimension. To meet FE, produce a D, EC and BD are drawn, and then they give us E1 being equal to E2, and they give it a parameter X, and then angle C2 is equal to Y. So let's see what all of this information does for us. Well, from here, given that we have a tangent over there, and this is a chord FB, we can immediately see that that's going to translate over there via tan chord. So we've got that, and then from here with the parallel lines we'll have corresponding angles. So that entire angle over there is going to equal X as well. Is there any other information that we can use directly to our advantage? Well, just initially that seems to be the be all and end all of it, and then let's go give a reason why each of the following is true. Well, for this, well, that's basically just the tan chord theorem that we spotted. Now they want BCD. Wouldn't you know it? That's exactly what we've been doing. So over there we had corresponding angles, and don't forget to quote your parallel lines. BF is of course parallel to CD. Radio. So what is next? Prove that BCDE is a cyclic quadrilateral. Well, first let's mark off BCDE. Now that's P and C goes over D, very ugly, and radio. It's that. Well, it's quite astonishing the pattern that you see in paper 2s. But something that we can take advantage of in terms of my astonishment is that, well, what we were asked in 9.1.1 and 9.1.2 over here actually is the proof required for BCDE to be concyclic. So what do I mean by that? Well, I'm just going to say that angle E1 is equal to angle BCD, which is equal to X. What's my reason? Well, I just proved it. It's proven above. Therefore, BCDE is concyclic. Why? Well, it's the converse of the external angle of a cyclic quad being equal to the opposite internal angle. So there we can see the configuration. That angle is equal to X, jump in, jump across. Well, that angle, the opposite internal angle, is equal to X as well, and that's good enough for that. Well, that's been proven. That's why we drag that along. Now they want to know which two other angles are equal to X. Well, what we need to remember is that once we've proved something, that we can use that the same way we use any of our axioms. So which two other angles are equal to X? Let's have a look. Well, E2 is equal to X. Now I can say that D2 is also equal to X, angles in the same segment. And then from D2, with the parallel lines, you can see this pre-marked angle X is now alternating with D2. So therefore, you can say angle D2 is equal to angle E2, which is equal to x, y angles in same segment. And then the other one would be angle FBD. So angle FBD is equal to angle D2, which is equal to x. What would that be? Well, alt angles. And why is that relevant? Because again, FB is parallel to CD, or BF is parallel to CD. Lastly, for this slide, we have the need to prove that B2 right over here is equal to angle C1 right over here. Well, let's close some space back now that we know where all the x's are, and get to proving our last right over here. Well, they want B2 to equal C1 over there. Rightio. So what does that entail? Well, we'll say that angle C1 is equal to angle BCD minus angle C2. So C1 over there is just a big angle minus that small angle. Rightio. So that's plain to see, which is why we don't need any reason. So that's just x minus y. Now let's have a look at B3 right over here. Well, angle B3 is equal to angle C2, which is also equal to y. Why is that? Angles in the same segment, which would mean that angle B2 is equal to, well, first let's state the angles and see what pops up. Angle FBD, so B2 is equal to FBD, angle FBD, so that's marked in yellow, minus B3. Okay, so take the small one and then I subtract this angle y. So angle B3. Reasons required over there. And well, we do have those values and they end up being x minus y as well. Therefore, or thusly, well, P2 is equal to angle C1. Both of them being equal to x minus y.